elementary STEM Olympia in elementary school. You did that? Okay. So they need volunteers from high school to judge crypto and set. So if you're interested in doing that, that is May 8th and or May 9th. So they're gonna send a bus or you can drive, and you can judge crypto or set. There's also a registration link. They'll feed you lunch, and it will be a school excused absence. So if you're interested in that, it's kind of at the busy time. It's May 8th and 9th, but if that's something that you're interested, there's the thing is up there, or I have a few flyers if you want to come up after.
I'm actually really happy. Choice.
Okay, so today we're gonna build off what we already know, but now we're gonna add double bonds and triple bonds. And then also we're gonna talk about two more things. One is called an isomer. We're gonna talk about constitutional isomers. And then we're gonna think about how molecules move. So that is our goals for today. So alkenes, remember we've been talking about alkanes. That's the boring carbon chain. This is a little bit more exciting. Now we have something called a double bond. We call that an alkene. They have, somewhere in them they have a carbon-carbon double bond. They have the general formula of CnH 2 times N. So if that's all you have, that is how you can figure out how many hydrogens there are. Or you can just count them. So we've got a double bond. We have already talked about this, but I'm just going to point it out again, is that if we have a carbon in a double bond, this carbon only has 3 groups around it. So if there's a carbon next to a double bond and has 3 groups around it, the bond angle is going to be 120. Do you remember what it was for an alkane? So alkanes have a bond angle of 109.5 because they have, in the alkane, they have 4 groups around them. So this section is like, don't forget what we just learned because we're going to keep using that. We're just adding double bonds and triple bonds. Okay, the other type of thing we're adding is an alkyne. So YNES. An alkyne, alkynes are compounds that contain carbon-carbon triple bonds. And they have this formula. We have however many carbons they have 2 times the number of carbons minus 2, that's how many hydrogens they have. Or you can just count. The smallest alkyne is acetylene. Have you heard of that? In welding, they use acetylene torch. So that's the smallest one. So if we have a carbon next to a triple bond, or carbon-carbon triple bond, we have a carbon bonded to this carbon, and we have a hydrogen bonded to this carbon. It only has 2 groups, so this is always a linear part of the molecule. So an alkyne, the triple bond around that is linear. Okay, questions, comments, thoughts yet? Okay. So this is going to be important when we're doing Alex, and on the test, you have to remember the ending. So alkyne, YNE, is for triple bond. ENE is for double bond. ANE is for boring just carbon, carbon, carbon. Okay. These are called unsaturated hydrocarbons because they contain fewer than the maximum number of hydrogen atoms. If you're drawing a condensed structure, you always need to show the double or the triple bond. Have you heard of unsaturated before?
Unsaturated.
Yeah, yep, this is, we'll talk about that on the next slide. This is the same thing. Unsaturated just means the hydrogens are, you haven't saturated the carbon chain with enough hydrogen, so it's unsaturated. I can't remember what this is called actually. This is our just regular structure. This is our condensed structure. So they're just saying like every time you draw the condensed structure, you still need to show the double bond. I think that kind of makes sense. Okay. So we're using the same pattern when we're naming alkenes and alkynes. If it has substituents or branches, those go in the prefixes, just like before. So we use commas, numbers to tell us where those are. Prefixes say, oh, there's 2-methyl, dimethyl. And then we find the longest parent chain. So if it's octane, if there's 8, that will be our parent. And then now we're to the suffix. So that's where, if it's an alkene, we're going to put, so if it's octene, if it has a double bond, but has 8 carbons in the carbon chain, we would use the ene as a suffix. So it'd be octene. And you've been doing that. You've been using the suffix ane, octane, or pentane. So now we just change it to ene if there's a double bond. If there's a triple bond, then our suffix is yne. So if there's a triple bond, but the longest carbon chain is 5, then it's going to be pent, and then yne, pentyne. Or if there's a double bond, it would be pentene. Okay, questions on that? So we're just building off of what we already know. You already know this. We're just adding. We have been using ane as a suffix. Now we're using ene or yne. Okay, so you have these rules. We're just gonna go through the rules together. So I give you the rule part. So you're going to number the carbon chain. So remember, we're finding the longest carbon chain. Number it so that the double or the triple bond, the multiple bond, is at the lower number. So start from the end closest to the double or triple bond. Okay. And then name the compound using the first number assigned to the multiple bond. So like this one, we're gonna start over here because it's closest to the double bond. So 1, 2, 3, 4. Oh, 4 carbons. So this would be 1. We had 4, so it's 1 butene. So 4 carbons is butane, but we have a double bond, so we change it to ENE, and the double bond is starting at the first carbon. Okay.
I'm confused. What does the first one even mean? Like the number of the carbon chain from the end that gives the multiple bond the lower number?
Yep. So
Doesn't make sense to me.
we can start over here. 1, 2, 3, 4.
Okay.
Or we can start here. 1, 2, 3, 4. We're gonna
Okay,
start.
So it doesn't matter where you start.
It does matter. We're gonna start on this side because this side is closer to the double bond.
Oh, so it just has to be closer to the bond.
Closer to the double bond. Yep.
Okay.
So over here, we could start here. 1, 2, 3, 4, 5, 6. Or we can start over here. 1, 2, 3, 4, 5, 6. But this way is closer to the triple bond. So we're gonna start on the right side. 1, 2. So this is 2, and then remember we had 1, 2, 3, 4, 5, 6. We had 6. So that's hex. We have a triple bond, hex sign. The triple bond is starting at the 2 position. So 2 dash hex sign. Okay. So it's not too different from what we've been doing, just we're adding some more stuff. Okay, questions on that? Okay. And again, just like chapter 12, the more you practice this, it's kind of like a game, it's kind of like a puzzle with all these little rules to follow. So the more you practice, the more comfortable you'll be with those rules.
So you would use the first number.
So the first number in the
bond.
Before
Okay.
the double or triple bond.
Okay.
Yep. So this one, carbon 2, starts having this triple bond.
Okay.
So that's why they're calling it 2 sign.
Oh.
Because
Okay.
the triple
that
bond
makes
starts
sense.
out at 2. Okay. Good. From the end closest to the double or triple bond. Okay. So we talked about this rule. 3. Okay. If the multiple bond is in the middle, specify its location using the first carbon multiple bond. So just lower the number if you can. It is optional to name the location of the multiple bond if it is in the 1 position. Kind of like if you have a cyclo and there's a group on there, you can either say 1 pentene, or you can just call it pentene because it's at the first group. And then you're going to, I don't know why I changed the numbering. You have this too. So name the parent alkene or alkyne, and then add a prefix for each of the alkyl side chains. So just the priority is we care mostly about the double and triple bond. And then if there's some groups on the chain, then we name those separately. Okay, so I would like you to try to name these. These are just alkenes, so you can name those. Okay, are you ready? What would you call this thing? 1 hexene. Okay, good. Oh, let's see. I can turn my pen. Let's turn on. There we go. 1. Oh no, this is. Oh, I can use my finger. I forgot. It likes my finger better than the pen. 1 hexene. Good. Okay. Or this another acceptable name would just be hexene for this one because it's at the 1 position. So either of those would be perfect. Okay, how about this one?
3-hexene.
Yep, good. 3-hexene. Good. So no matter which direction we number this, it's going to be at the 3 position. Yep, good. Okay, and the last one. Good. 2. And this one's actually still hexene. 1, 2, 3, 4, 5, 6. Okay, good. Does that make sense? So that one starts at 2. You have to put the 2 there. 1 is optional. This one would be 3. Okay, how about let's see. We'll skip this one. I realize I have a lot of examples. So try this one. Okay, what do we think? Do we have a name?
Think so.
Okay, what do you think?
2-butene.
2-butene.
I don't know if that's 2. That 2's right, but
Okay, I think that. Yep. Either way, we number this the butene, so we could go 1, 2, 3, 4, or we could go 1, 2, 3, 4. Yep.
or we could even
Yep.
go on the top and then over.
Yep. So either way. Yep. And then we have, if we go along this chain, we do have this methyl group. So we need to name that. So how would we add that?
Okay, so then
Should we put it at the 2 or the 3? Should we count it this way or this way? What do you think?
The 2.
Yeah, I agree with that. So we're going to minimize the methyl group. This way or this way, the butene is fine, but that's a tie. So then we're going to minimize the substituent. Good, so that would be 2-methyl,
Then it would
2-butene. Good. Okay,
okay.
you okay on that? Good.
Yeah, that makes sense.
Good.
I just forgot about the methyl group.
Okay, yeah, good. Yeah, don't forget about those substituents. Okay, good. Is this the same one? This looks. Oh, there's a chloride group. Okay, try this one. I didn't see. I saw this one. Okay, what do we think? What's this one? What should we call this one? Okay, 1 chloro, oh, 1 dash chloro,
3 methyl.
2 methyl,
2 butane.
2 butane. Okay, so let's see. This is gonna be, check this again. So let's see. So you're naming from this side. 1, 2, oh that's a 2. 2, 3, or 1, 2, 3.
Can I
Yeah,
on the
that's
starting
not
for
3 methyl, that's 1 methyl.
Do I start with chloro?
Oh, so this is, I would start with, yes, I agree with you. I just think that this is 3 carbons.
Okay.
So then
Yeah.
it's gonna be
Propane.
propane, good. Propane. No, that's propane. We're just practicing. We're just practicing. Okay, does that make sense? Okay, good. So we're starting, and I agree with you. We're gonna start from the chloro side because that reduces our double bond. We care about that most. Chloro happens to be on the 1 position, and then we have the. I guess this would be
Wait, why?
Yeah, and then
Oh,
these
wait.
2. We would put that 2 there. Yep, 2 methyl. So 1, 2, 2 methyl, 2. Oh, this one I think also would be. Oh, I see. So you accidentally. I was doing that too. This is you're counting that as a carbon.
Yeah.
So this should be a 1. So the double bond starts at the 1 position. Okay. So 1 chloro, 2 methyl, 1 propene.
Do we have to put the 1 since it's in the first spot?
I would, but I don't think you have to. Because if you don't include it, then you assume that it's in the first position.
Yeah.
Okay. But I would just for clarity. Okay, other questions? Good question. Okay, let's keep going. Yeah, try this one. This is our last naming, and then we'll draw some. Yes.
Okay, I'm gonna.
Oh, you're ready.
Yeah.
Okay, what do you call it?
I'd say 2 dash methyl or methyl. I don't know. Because I forgot we have to do the methyl, but I also don't. Because we didn't do the methyl on the first couple ones we did.
Oh.
But were those not methyl?
Yeah, we did, I think. Oops, let's see. We named that one methyl.
Or before that? Never mind.
Okay. So this one, I would start over here. So you're saying you didn't include a prefix, so I am assuming that the double bond is at the 1 position. So, and that's true, but we can't count both ways. So that's 1, 2, 3, 4, 5. So this would be 4.
Okay. I'm just used to
Well,
starting over here.
wait.
Yeah. Doing the last
Why-
one. So I just
Oh,
see
okay.
myself.
Yeah. Okay.
Why
Yep.
is it that way though?
Why is
does it have to be
Because of
that
the
way?
It has to be that way. Yeah, maybe it's.
Okay,
Um,
that makes sense.
it overrules the rule about starting by the closest branch.
Yes, this rule overrules that.
Okay.
So we start with the closest double or triple bond. That's the overrule. Yep. So 1, 2, and then if like there was one that was tied, you would start. And that's the next rule. That you
Would
follow.
that still be correct though, just 4 methyl?
Pentene. Yep. You could also call this 4-methyl 1-pentene. Because the double bond is at the 1 position. But technically you don't need that. Okay.
That would still be correct, the other one?
Yes.
Okay.
There are, from last year I remember, usually Alex accepts both, but I can't remember, there's like one question that Alex does it one way, only one way, and I can't remember which way. So if you get something like that on the test, we talked about it, I will give you the points.
Okay.
You just have to get through the homework part.
Okay.
So kind of figuring out what Alex wants. Okay, try to draw these. I'm realizing we have no alkynes, so I'm gonna write myself a note. We need to practice now. I don't know why I just totally ignored all the alkynes. Hey, is there somebody who wants to come up and draw the first one for us? Just use your finger, PowerPoint like so. You want to go up there, Sebastian?
Sure.
You can take your notebook with you if you. That's totally fine. Show us what you got.
Okay, so for this one, the trichloral, I got, so there would be C or
Yep, just draw with your, yeah.
CH. Then there would be a double bond.
Okay,
Then there would be a C, then two chlorals on one, right? I don't know if this is gonna be correct, but
so that would be your 2 position.
that would be the 2 position.
Yep.
So then the chlorals would go here then.
Yep, yep.
Okay, so
You wanna,
I'll erase that.
yep.
How do I don't know how to erase it.
Have a black GM
Do I click undo? Or
and a gray Toyota that are parked in